Hello everyone, today we will be focusing on inserting a node inside of a balance tree, and without any further hesitation, let's get started. Now focusing on inserting a node into a balance tree. So overall, first thing that we're going to do, as usual, is that we are going to include a library. So we're going to include iOS Stream, or depending on whatever IDE you use. We're also going to include algorithm. Then we're also going to include our header file that we made. TreePrinter.h, and then using namespace std. And so we'll have a class. We're going to use this type of balance tree called AVL tree. And then we're going to have a public instance right here. We're going to construct our node, where we will have our data point called key, and we're going to initialize the node on the left and the node on the respective right. And then we'll have int height, and then initializing the nodes as well with respect to the data point. Key of k, to left null pointer, and then the right null pointer. Height already initialized as 1. Just gonna put this out. There we go. So putting that there. Now we're going to initialize our root, node root, AVL, and our class instance tree, starting with the root, and then null pointer. This is how we initialize first. And what we will do is that we'll have our height, get a balance, check the right side for insertion, and then check the left side for insertion, and then we will insert the node. So first thing we'll do is that we need to check the height. We do so by having a integer function height, int height node with return node or node at a respective height. There we go, and then we'll get the balance, int get balance of the following node with respect to the node, and then we will return a node or the following height of the node on the left, and minus the height to get to where we are inserting it on the right. Here we go, and then we're going to check the right side for insertion. We do this by a rotation in this case, and I'm also going to put this right here just to, have it be quiet. So node right rotate for node of y. It's going to be node at x equals y at the left, and then node of t2 is going to be x at the right. X right is going to equal y once we are rotating on y left will be equal to t2, and then we are going to get the height of our following max height left. X with respect to the height equal max height x to the left, then height x to the right plus 1, and then we are going to return x. Yep, looks good. Now we're going to check for the left side for insertion. We're going to do this by left rotate. So node left rotate with respect to node of x. In that case, we're going node y is equal to x right. Node t2 is equal to y left. Y left is equal to x. X right is going to be t2. X to the height is going to equal max of the following height with x left, and then height of x right plus 1. Make sure parentheses are reset in place, and then we're going to have y's height equal max height with y left and a height of y right plus 1. And then we're going to return y. Now, next part, we will insert the node. We can do this by the following node function that we have. Node insert for node int key as the following parameters that we have. If there is no node, we're going to return a new node with a data point indicating that edge case. And then if the key is less than a node for the at the key for our insertion, we're going to insert at the left. Node left equals insert with node left key, and then else if the key is greater than the node key, that means we will go to the right and then insert the node at the right with the respective key as well. And otherwise, in our base case, we will return node and check the height. Right, and then get the balance as well, and check the balance of the tree. So check the height with the following node height to see if there's any adjustment. Equal 1 plus max of the height with node at the left, height node on the right. Get the balance by doing the following: int balance equals the function we made for get balance of the following node. And now we're going to put in the Boolean conditions to check the balance of the following tree. If the balance is greater than 1 and the key is less than the node at the left with the respective data point of the key, then we're going to return right rotate of the following node. Then if the balance is less than -1 and the data that we have is greater than the node at the right data point, we need to return left rotate for the following node. And then in this case, for the next condition, if the balance is greater than 1 and the key is greater than the node at the left data point with respect to the key, we're gonna have nodes, the left node rotate with node left, and then return right rotate for the following node. And if the balance is less than, final Boolean condition, if the balance is less than -1 and the key is less than node to the right and the respective data point of the key, then we'll have node right equal right rotate with the right node. And we will return the left rotate for the following node as well. Finally return the node. In that case, now we will have our main function as well, after we made our AVL class. So the main function, the way it's going to be built out, is that we will have AVL tree and call this AVL, and then we're going to call upon our TreePrinter and call this printer, as a following from our header file as well. Then we're going to have the AVL root. We're going to have 3 instances of inserting avl.insert, avl.root with 10, and we're going to have other ones as well. 30. And then we're going to output nodes inserted into AVL tree and L and printer dot print pretty. Yep, we got that. We have AVL dot root. The initialize that and indent space 0, and we're going to return 0. There we go. And I also have the corrected TreePrinter as well in the following solution at the same time. So in that case, we would do that. But yes, this is inserting a node into a balanced tree. And now let's go over and try to figure out how do we remove a node from a given tree. Hey everyone, thank you very much for taking time to watch this. If you found this video helpful, be sure and feel free to please like and subscribe. And if you have any other questions or suggestions, please put them in the comment section. And as always, take care. Cheers. Bye-bye.